Okay, we'll continue now. So the next lesson isn't too difficult. So let's have a look at it. Right. So just a little bit of vocabulary now. Are we ready to continue, guys? Guys. Ready? Continue. Thank you. So, a little bit of vocabulary before we start. Now, I wonder if anybody knows precisely the difference between a sequence and a series. Because in English they sound like the same thing. It's a little bit of a difference though. No. No. No.
Sequences always have the same difference, and
No.
series.
No. 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 Let's try that.
Sequence is like a recording.
Yeah. And a series then?
Is random.
No. That's getting more wrong. Anything else? Nobody knows the difference? No?
With order, not with order. Series is ascending.
Good, but no.
Sequence can be either ascending or descending.
Okay, it sounds like we're just making things up now. So like, sequence is a ham sandwich, but series is a chicken sandwich. Like, why not? Sequence is like this. 1, 2, 3, da da da. And a series is like this. 1 plus 2 plus 3 plus da da da. The difference, they're both a list of numbers. The sequence is each separate number, and a series is you add all the numbers. So in other words, a series is like, you can think about it like this, a series is a sum of a sequence. It's a small difference, but you know, it's important to know this. So what precisely do I mean by a sequence or a series? Well, basically they're both like a list of numbers, but they're a list of numbers that obey a rule. So you can predict what's going to happen next. So obviously this sequence is trivial. Like, what's the next number after 3? 4. And your kindergarten teacher will be very proud of you for knowing this. But let's have a look at a harder sequence now. Okay? Not so easy. And maybe we can try and figure out the next number. So let's say, for example, I have something like this. 3, 6, 9, 12. What's next? Yeah, but what's the rule here? Add 3. Add 3, yeah. Okay, let's say we have something like this. Okay, what's the next number? Getting a little harder now, isn't it? Is it? Yeah, very good. But what's the rule?
Increasing in
The
the addition.
addition is increasing by 1. Each time you add 1, and that rule itself increases by 1. So here we add 1. Then we add 2, then we add 3, so then the next one you add 4. Okay. What about this sequence? Mm-hmm. 11, yeah, why? These are prime numbers. Prime numbers. Right, what about this one? 25. Why? Square numbers. Okay. Right, let me give you a really hard one to think about. Hang on, I lost track. Yes, it is. Now, hang on, let me think. Right, what's next?
1, 1.
No, I just want the next number.
9?
No. Hang on now, just before you start guessing numbers, alright, if you guess the right one, I'm going to ask you for what the rule is. If you don't have a rule, you're going to look like a fool. So, if you guess, I want the rule as well.
That's 5. 5, yeah.
8113.
You add.
5, okay.
Okay, you add 1 plus 1 plus 1 equals 3.
Yeah.
3 plus 1 equals 4.
Yeah.
1 plus 1 plus 3 plus 5 is.
But how many numbers do you add previously? So you, oh, a minus! No. I would at least tell you it's positive.
1. Yeah.
It's 1?
No,
It's 5. Because you're doing 3 plus 1 plus 1. Yeah. So your rule is to add the last 3 numbers. Which looks okay because you'd start off with 111, so the next one is 3. But then the next one should be 3 plus 1 plus 1. So this guy shouldn't be a 1 then. Should be like a 5. Good try, but not quite that. Nope, okay. The next one is obviously 6. Let me explain why. Obviously 6. No. Okay, so listen carefully. This sequence is a classic example of how it can be very, very difficult to figure out what the rule is. Okay, so this is what you do. And now the rule requires listening very carefully to what you're saying. So first you just start off and you write down the number 1. So you just begin with the number 1. Okay. Describe what you have. Here you have one number 1. You have one number 1. Now describe what you have. You have 3 number 1s. Now describe what you have. You have 4 number 1s and 1 number 3. Now what do I have? I have 6 number 1s. Yeah. But that's my point. There's a rule, but it's not easy to see what the rule is.
What's the second? But how do you know how many 1s do you get? Like you could have a 1 after.
No.
Yes, because
What's the
second?
rule?
Is 4 1.
What's the second threat?
What's the rule?
Describe how many.
Yes. Here's the rule. So, write down the number 1. Hang on, I don't need it. To start. Then say what you have, e.g. x of y. So you can have 5 number 1s, whatever it is, and write each number you speak. So if you say I have 3 number 1s, then you write down 3, 1. Yeah. It's not supposed to be a real mathematical one. It's only to make a point that there can be a rule, but it can be impossible sometimes to see what the rule is. It looked like it was random. It wasn't random.
Weren't you saying that you were going to count how many ones you had? Isn't that what you're doing?
More or less, like, because I have to say how many ones I have.
Okay, but why didn't you add the 1?
But why would I add a 1?
Why wouldn't you add the 1?
That's the 6.
Because you're still counting it.
There's the number 1. Right. Tell me what I have.
1.
Now give me a sentence.
You have 1 number 1.
I have 1 number 1.
You have 3 number 1.
Now what have I got in my possession?
4 number 1.
I have 4 number 1s and I have 1 number 3. I can't just add a number in. I'm actually following a logical rule here.
Which is you're counting what you have.
Yeah.
Couldn't you put something that you don't have?
But then I'm not following my logical rule. Yo, that's like that'd be like saying this. No. That's like if I said this. What's the rule here? 3, 6, 9, 12. What's the next one? Yeah, but why just stick in a 1? Why not? You know, that's what you're saying. You know.
But there you're counting the amount of numbers you have,
Yeah.
Couldn't you put in a number that you don't already have?
But
And
what-
counting after that, wouldn't that be right? If you were to continue the sequence after that one number, couldn't you
tell
count
me,
it?
no, but tell me.
What's like?
Why is that different to this? 3, 6, 9, 12, 1.
No, because there's a sequence.
Yeah, and in my one there's a sequence as well. You see, your friend is trying to save you because you don't realise what you're saying.
Why don't you say you have one number 4 then?
Huh?
Why don't you say?
Oh, I will.
one
Like,
number
I keep continuing, so I will eventually say I have one number 4. Yeah.
The second phrase
number
stands
one,
for the
number 3,
command number.
one number after this.
Hang on, one at a time. Yeah. The second tree.
is stand for the
It was me saying I have one number 3. It was saying that about that one. Yeah. Right at the back.
Yeah.
Yeah.
I had a question.
Yeah.
According to this rule, there could be still 2 different sequences. Because what if you say, rather than I have 3, 1, after that, if you, like you can say the order of what.
You're right. So that could be a different sequence, a different rule. Correct. Yeah. Just like, you know.
No, it could be a different sequence with the same rule.
Yeah, it could be. It could. But even this one here, you see, like I had 3, 6, 9, 12. What's the rule here? Plus 3. 1, 4, 7. What's the rule here? Plus 3. Same rule, true? Different sequence, true. So just because it's the same rule doesn't mean it'll make the same sequence. Because you can change the conditions. What condition did I change here to make a different sequence? A first term. So like in your example, you know, you could do something like that too. Yeah. So my point, the rule doesn't uniquely define the sequence. Because you'll need to specify other things like where to start. This is a true point, that's valid.
Sorry,
Yeah.
I'm just gonna say something now. 2n plus n.
Yeah.
Okay, I thought that each sequence is supposed to have its own way in which you can express it in the form of
No.
n.
No.
No?
No. 100% no.
Not all sequences have to have that.
Correct. That is false. Anything
So
else?
is there a particular sequence that doesn't have that?
Yes. And that's what we'll do in a moment.
And it's logical reasoning.
Yes. If you give it some time, I'll show you that one in a minute. Okay? One last sequence before we look at the n situation. 3, 1, 4, 1, 5, 9, 2, 6. What's next? No. Now this isn't as hard as the last one. I'm hopeful someone will spot this. Okay, I'll tell you. More minutes. 8, no. No. 12, no. 3, no.
The 9 to 6 makes no sense.
2 and 8 at the same time.
No, 2 and then.
No.
Right?
No. 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 Does nobody want to give me a negative answer? Just -6 or something?
Is that a 4 or a 9, by the way?
Sorry.
Is that
That's a 4.
Is that?
Oh, sorry, that's a 9.
Just that doesn't make it not make sense.
Wait.
I do admire the confidence in this class to figure it out. Like that is good.
-7. -1.
I was waiting for a minus. Thank you. That's wrong. Anyone else? No. Okay. Nobody's got it. It's 5. Can you see it now?
This one is just evil.
Ah, well, I thought someone might recognize the numbers. 3.1415. You're supposed to, yeah. Just like you know your phone number. You're supposed to know this. Yeah. It's not a real math example, and I'm just trying to make the point that with a sequence there's a rule to make the next number. But sometimes this rule is extremely difficult to see, which is here. But now that you saw it, it doesn't look so difficult. Yeah?
Oh, that option.
That would be very cruel. Yeah? No. No! Right, anyway, let's continue. So obviously, we need some procedure for actually figuring out what the rule is. So, in the syllabus and the exam, there are two basic rule structures that you could have. Now, the point of all these examples is to show you that you have great flexibility in forming the rules, but there's so much flexibility that it would be impossible in the exam. So they confine it to two basic rule structures. The first one is what you were suggesting, which is writing the formula in terms of n, as an expression, as an equation. So for example, if I write something like un equals n squared, n equals 1, 2, 3, what I'm saying is my sequence, I can find it by just taking n and squaring it. So u1, which represents the first term, that would be 1 squared, which is 1. And u2, which is the second term, would be 2 squared, and that would be 4. And u3, which is the third term, squared, that would be 9. So if you actually look back at my examples, some of them you can write like this one here, 3, 6, 9, 12. You could really think about it and figure it out. It would be un equals, now you have to start at n equals 1. So un would be 3 plus n minus 1 times 3. So if you put n as 1, what does this formula equal? 3 plus 0. If n is 2, 2 minus 1, 1 times 3, plus 3, 6. Okay? Now this one is a little bit harder, but you can actually still write it as a formula. It's a little too hard for the exam, but actually it would end up equaling in a formula that looks a little bit like a quadratic. But that's not part of the course. This one here, no, you can't write this as a formula. This one here, what would be the formula? N squared. And this one here is a no. And this one here is a no. So, let me give you a formula, and I just want you to write down the first, just give me the first 3 terms, okay? So here's the formula, un equals 1 over n factorial. And I want the first 3 terms here. Yeah? No, I'm not interested in your formula, unless it's something really juicy. I doubt it. Maybe later. Okay, so what's my first term? 1. 1 over 1 factorial. And my second term? A half. Yeah, 1 over 2. And my third term? 1 over 6. Okay, so this is what you might call a direct approach, a direct formula, an explicit formula. And I think this is everyone's familiar enough with this. It makes a bit of sense. Let's have a look at now the next one, where it's not written using n. Okay, so this one's a little bit tricky. Can I scroll down? Yeah. So sometimes you have sequences that look a little bit strange. They look a little bit like this, as an example. They tell you what the first term is. So let's say something like x4 equal, or sorry, what am I saying? Sorry, x1 equals 4. And then rather than giving you the formula directly, they give it to you what's called recursively. So that would be like this. xn plus 1 equals 1 plus 1 over xn. Now you might be thinking, how do I interpret this formula? Well, you interpret it like this. If xn represents the nth term, then what would xn plus 1 represent? The n plus 1. In other words, the next term. Okay? So you can interpret this as meaning the next term. Yeah, that's it. So x2 would equal 1 plus 1 over x1, yeah, which is 4. The next term is 1 plus 1 over the term that you're at. So let's test it out. If I start at 4, then what would be my next term? It'd be 1 plus 1 over 4. So that's just 5 over 4. And what would be my next term? It'd be 1 plus 1 over 5 over 4, which is 9 over 5, I think. So it's called recursive. The reason it's called recursive is because you take the thing that you're at and put it back into the formula, it gives you the next term. Then you take that and put it back in again, and you get the next term. So it's a loop. This is what recursive means. I'll give you a simpler example now. Let's say, for example, I tell you to start at the number 1. And my rule is the next term is the last term multiplied by 3. So what would be my next number here? What would be x2? x2 should be 3 times x1. So what would that be? 3. Okay, what would be my next term?
9.
Be 9. And my next one? 27. Because the next one is 3 times the one that you're at. So you put 1 in, you get 3. You put 3 in, you get 9. You put 9 in, you get 27. It's a feedback. This is called a recursive sequence. Okay, let's try another one here. I'll let you work this one out for yourself. So let's say I'll tell you to start at 2, and my formula will be let's say the next term. I'm tired of using next. I want to use a different letter. U. U1 equals 2, and my next term will equal the square root of my last term. Okay, so give me the first tray on your calculator when you're ready. Oh, and you can give it to me 4 decimal places. Yeah, so the next one would be 1.4141. And the next one would be 1 point. What the heck is called it now? Oh, spam. Right, what's the next one? 1.1892. Yeah? 1.18. Yeah, well, I just want these 3. Yeah. Now, when you look at these sequences, sometimes something quite interesting can happen in their behavior. So I'll give you 3 examples. Using your calculator, I want the first 5 terms. So here's my first sequence. And you know what? To make it easy, I'll say in all cases, start at 1. Okay, so my first one is u n plus 1 equals minus un. My second example, b n plus 1 equals 1 plus vn. And my third example, w n plus 1 equals 1 plus 1 over wn. I want for u, v, and w, I want the first 5 terms, okay? So the first 5 terms
What's 5 times
of each. And you already know the first term. I said for each one to start at 1. Really? Have we got any of the sequences done?
First one, I think it's just minus one.
Correct, yeah. U, the first one is 1, the next one will be minus 1, the next one will be minus 1, so that's 1, minus 1, 1, and we kind of see what's happening here, don't we? Right, the next one, first one is 1, what's the next number? 2, 3, and 4, and we see what's happening. Right, the last one will be 1, and then 2, and then what would it be as a decimal? Sorry, 1. It's 1.5, is it? No, 1 plus a half, 1.5, isn't it? Yeah, and what would be the next one? 1.67? 0.6? Are you sure? 1.67, is it? Okay, and give me just one more. 1.6. Yep. Now, the point I want to make is that there's actually a different behaviour. There's something happening in the first one. How would you describe what's happening in the first one? Like, give me a word that describes its behaviour. Come on. Some of you have really good English. Give me a word that describes what's happening to the number. It's like recurring. That's another word for that. Yeah, but this particular way. It's like recurring. You could say it's recurring, but more normal would say it's periodic. It's periodic. Yeah. Now, what way would you describe what the second sequence is doing? Yeah. But more than just increasing, because it's increasing without a limit. We all agree that this will just keep going.
Linear.
Yeah. So we need a adjective for infinite. Not too. Yeah, you're kind of close. Not quite unlimited, but we need an adjective that describes something moving to infinity.
Linear?
Yeah, not true. It is linear, but describe an adjective for describing something moving to infinity. Yeah, we're good. Exponential, not quite. I mean, a bit more general than that. We say divergent. Yeah, and this last one here, we describe it moving to a limit, approaching a limit, and this one we call convergent. Because do we think this will keep increasing? No, because it went up, went down a little bit, went up again, so it might be, trying to level out. What's this one doing? It's shooting up to infinity. And what's this first one doing? It's moving back and forth. So these are the basic adjectives we can use to describe a sequence. Okay, I want to show you how you can actually use your calculator here to make the sequence quite quickly. So, if you can all, now this works on any calculator, so if you can all watch closely. I'm going to make the last sequence without having to type it in all the time. So, watch carefully. First, you enter where you begin. So what number do we begin at in the last one? 1. So you type in 1 and you press equals, and then you clear it, you press AC. Now, don't do this, but maybe you can tell me what the answer would be. If I pressed answer, what number would I get on the screen? 1, because that was what was previously on the screen. So if I type in 1 plus 1 over answer, then I'm getting equals, I'll get 2. If I press equals again, I'm actually calculating 1 plus 1 over 2, because 2 was the answer I just got. So the next one should be 3 over 2, which it is. If I press equals again, I think I get 4 over 3, 5 over 3. And then 8 over 5. And then 13 over 8. Now look, keep watching. Now I can hear the tapping. Just watch. Now, it's no longer changing. So it has converged to this number. It's converged to this number. So what's that? It's about 1.618.
Yeah.
1.618. Roughly. Does anybody recognize this number in maths, by the way? It's not just a random number, it's actually very good, yeah. Do you know what it's called? Very good, golden ratio. This symbol. Yeah. Now where did you see that number? TV, movie? Textbook, okay. This number here. If you've not seen this number before, you can have a look at it. It actually is an important number in maths. Golden ratio.
Why is it golden?
No, I'll let you look it up. It actually has a lot to do with architecture and things like this. Yeah. I think there was a number used by Roman architects a lot for the ratio of the length to the width of their buildings, you know. Greek, is it? You got it there. Good stuff. The Greeks used it a lot in their architecture then. Yeah. You also see it appear in nature as well. I think something with something with a sunflower or something. I can't quite remember. But you can look it up anyway. There'll be many pages on it. Okay. So you can start these for a few minutes. First and last, and 5, 6, 7. So first and last. Yes, come show me now. Right. What's the deal?
Couldn't we see we have 2 3s
Yeah.
or 1 4 and 6 1 works, but couldn't we add a 1 and a 4? What I'm trying to say is that the sequence continues after the 1 digit, so you could have multiple different answers. You could have a 1.
Yeah. So the way you think about it is you say 1. That's step 1 on the ladder. Then the next step you say what you have. What have you got? 1 1. Now you say what you have in total. You have 3 ones. Now you say what you have in total. You have 4 ones. No, 1, 2, 3, 4 ones and 1 3. Now you say what you have. You have 1, 2, 3, 4, 5, 6 ones, 2 3s and 1 4. So if I was to write this sequence out, it would be 1 1 1, 3 1, 4 1 1, 3 6 1 2 3 1 4. Yeah. I have no idea what the sequence is called. Somebody showed it to me in university, and I don't even know what it's called. I'm sure it has a name.
Was he a demon?
Yeah, kinda.
This seems out of hell, honestly.
Kinda.
Like, I had the right idea that it could be different things. I didn't see that it was like it's in this way.
Yeah, maybe the triangle's a little bit clearer. Anyway, no matter. It's not an exam topic.